Welcome, Paul, to the IoT For All Podcast. Thanks for being here this week.
Thank you for having me, Ryan. It's really, really nice to be here and to be talking to you about all the exciting things that we're doing at Kigen.
Yeah, it's great to have you. We've had a great relationship with Kigen for quite some time, so I'm glad to have a member of the team on to talk about just what's going on in the space that you all work in, help loop in the rest of the industry and the listeners out there on how important the space you all work in plays a role in the growth of this IoT industry that we're all very excited about. To kick things off, perhaps maybe you can just give a quick introduction about yourself and Kigen.
My name is Paul Bradley. I'm the VP of Solution Sales at Kigen. I'm based in Marseille in France. So just to give you a few words about Kigen. So Kigen, we're looking at really simplifying and lowering barriers for folks who wish to leverage cellular IoT. So we're doing that through several different simplification steps around leveraging the eSIM technology, and as well as the integrated SIM technology, to be able to use the SIM as a platform to ultimately secure the Internet of Things by providing a root of trust that we can use pervasively in cellular IoT devices and later in all types of IoT devices, to be able to ensure the authenticity of data that's being collected. Because again, a chain is only as secure as its weakest link. And of course, edge endpoints are out there. Data is being collected, but unless we can get that data securely into the cloud, unless we can ensure the authenticity of transactions between devices, in the concept now that's becoming very popular, which is called the economy of things, then where devices can interchange between each other, then the trust won't be there. So the trust will be lacking in the Internet of Things. So we really want to instill that trust from the ground up. We're always encouraging things like security by design, because if you don't bake it in from the very beginning, then a game of cat and mouse typically will open up. We remember, I always kind of refer back to the iPhone jailbreaking scenario, where you had folks that were trying to sideload applications into iPhones in early generations because there wasn't that enclave there to instill trust in the devices, and so that became something which is a good example of what we're really trying to do. We're trying to bake in the security using integrated SIM or eSIM, and then use it as a platform for the developers to secure what they need to do.
For our audience's benefit, would you kind of talk about just how big of a problem this is for the industry when it comes to the security through the eSIM and the connectivity piece of an IoT device, an IoT solution? Why is this so important to address, and how big of a problem is it for those out there maybe looking to understand why this is something they should be really focusing on?
That's a great question, Ryan. So we've seen a massive boom in the adoption of eSIM in different cellular IoT devices, and again, I think that this is largely down to folks wanting a freedom of choice. If you're deploying, whether it's a consumer device that's going to be in somebody's home that's using cellular technology, or whether it's something that's part of a fleet of devices, or it could be even a cellular connected smart meter or something like that. Either for regulatory reasons, either for personal choice reasons, either for commercial reasons, having the ability to be able to load the cellular subscription of choice to address a certain geographical area, having the possibility to move that cellular kind of subscription from one carrier to another, it's extremely important, because otherwise you feel that you're locked into a given carrier, and they could potentially abuse their position if you don't have the possibility at least to change. Again, in most cases, it's an insurance. It's you never change your carrier unless they upset you somehow. So it's the same with smartphones and other devices. You rarely change. However, you need to have the possibility to change if you want to. So this is something which I think has really boosted that traction in the eSIM space. Now, eSIM technology has evolved over time. So we started off with quite a limited standard, which was a machine really for machine to machine IoT devices, or the predecessor of IoT, the machine to machine space, where it was really kind of driven around fleets of devices. So, you had kind of a fleet of smart meters, you'd have a fleet of something that you wish to, or automotive, I think, was a very, very strong proponent of this technology, whereby you had a fleet of cars and you wanted to adapt the connectivity for each vehicle to a carrier that was local. So this was this was a very, very complicated, however, to deploy technology, not from the device perspective, but from the back end perspective, because every auto manufacturer had to connect to every cellular network that they wish to use. So it kind of was slow to adopt. But then the big thing that we're seeing kind of in eSIM is now in the consumer space, where you've seen in the US for the last 18 months, iPhones have no longer had the SIM slot. So you can only get your profile in there using eSIM technology. You can only get your subscription into the device using that. And I think that freedom of choice and the digitization and simplicity that comes with that, where you're no longer having to go and source a SIM card. In the US, you might not have noticed that so often because a lot of the SIMs were pre-kitted. However, in Europe, typically, the SIM came from the operator, the cellular carrier, and the device came from them as well, but you still had to do the insertion. So it kind of simplifies it and it digitizes a lot of the processes. So that's kind of something which has become something to solve. And then with the new IoT standard, which has just been let's say released as a technical specification at this stage, we're bringing that same freedom of choice that we have in the consumer market without the complex kind of many-to-many integration that we had in the M2M, where every automaker or every meter vendor had to connect to every cellular operator. So we've got rid of that, and we've made it kind of such that any EUICC can download a profile from any network provider, and that you also have that remote control over the devices, whereby you're able to you're able to kind of control your fleet of devices and say, I want to move all of these devices from network A to network B. So if you want to do so.
Yeah, I actually had my first encounter on a consumer level with eSIM last night. I was switching a phone from one carrier to the other, and I've never done that before. All my phones have always been on the same carrier, so just very easy to just keep going. But inside of the settings, you got to see the different profiles that your phone has been set up for, and switching between the profiles from carrier A to carrier B, and then how that whole activation process started. It was very interesting and very cool to kind of do leading up to, and it just out of pure coincidence, our conversation today. So if you think about how that can possibly make things convenient for a fleet of devices out there, you can kind of start to really understand why eSIM is able to support global wide deployments, right? You're able to switch between those network providers as a device moves between different provider regions and things like that without losing connectivity, which I think is awesome. When it comes to that process, what are some of the challenges that exist with eSIM, using eSIM for those worldwide global deployments that we know are growing day by day and becoming more viable in the IoT space?
I think one of the key kind of challenges is what we call the permanent roaming restrictions. So some geographies, they don't allow a SIM profile from outside of that country that's been issued from outside of that country to connect for more than a certain period of time. And that's something which is kind of a challenge, because in certain types of IoT devices, again, IoT is a very vast subject, but you might have devices which might need to stay in a given territory for longer than the period that's authorized by the government. And so one of the key challenges is ensuring that we can overcome that by using eSIM technology, whereby if you arrive in one of these territories, then you can download a local profile easily, and when you leave the territory, then you might go back to your other profile. So you can use a local connectivity provider where there's restrictions, and then you can go back to your kind of maybe your normal worldwide provider when you leave that territory. So it's these types of things that they're important challenges to consider, where before you might have had to source a local SIM card. You might have a vending machine at the airport which sells local SIMs. Now, kind of that goes away, and everything is invisible. And again, we have a lot of use cases around logistics or asset trackers or whatever. At the end of the day, you might not know how long a truck is going to spend in a given country, making deliveries or whatever. So again, it can be it can be tricky to manage, and we need to make sure that we take that into account. And eSIM technology, I think, is a good solution for that type of a use case.
Something I wanted to go back to, you mentioned earlier about the new eSIM for IoT standard. How is that really driving adoption, or how do you see that being something that is going to drive adoption, how that changes from kind of where we've been to where we are now?
I mentioned kind of like earlier on that there's three different families of eSIM technology. So there was this M2M one, which was very complicated to deploy because of these many-to-many interconnects between every mobile operator and every enterprise or OEM who wished to use their connectivity. Then the consumer one was a great standard. It's had great traction, and we see it in appearing in more and more consumer devices. However, there's one key principle that's mandatory in this standard, which is something called user intent. So you have to, as a user, either scan a QR code or click a button to say, I wish to download this subscription to this device. So there wasn't a kind of fleet management aspect where you could automatically move a lot of devices from network A to network B. So in the new standard, and again, neither of those two standards were adapted for constrained networks. So typically, a lot of the IoT space, which we kind of forget about. We see the consumer devices, which are quite rich, but we also forget about like things like that are buried under the ground, like smart meters that might be running on very, very low bandwidth cellular bearers like NB-IoT or LTE Cat-M. So these are kind of the very, very low end of the spectrum. So there's three kind of main things I would say that are benefits of the new eSIM for IoT standard versus the M2M and consumer ones that came before it. One is, firstly, the level of belief in the specification. I think it's incredible. Everybody we spoke to at MWC was asking, kind of, are we there yet? Are we there yet? Are we there yet? And everybody's waiting for it because they know that it's the solution to a lot of the problems that were there. Because again, the openness that it brings to be able to download any EUICC profile to any EUICC in any device. So you can use any operator on anything without the constraint, without the complex integration, and without the mandatory user intent. This solves a lot of problems. So this is the very, very first thing: the openness and the belief that's there. The second thing I'd say is a benefit is it's designed with the constrained devices at heart. So the fact that it copes now with NB-IoT and LTE-M. So we have a new entity that's sitting either under the control of the enterprise, or it could be part of the device management platform, or it could be even some of the MVNOs running this, which is called an EIM, an eSIM IoT Remote Manager. I call it the remote control. It's the remote control for a fleet of devices. And so thanks to that element, it's the one that's saying switch from profile A to profile B, download profile C. It's kind of the remote control over your fleet of devices. And in fact, this new element also can transcode these kind of commands over whichever protocol we need. So if we want to use NB-IoT, then we might want to use CoAP rather than kind of a standard kind of TCP/IP HTTPS connection. And so therefore we can use that one. So CoAP is perfectly adapted for very constrained bearers. Similarly, before we used to have a pretty heavy dependence on SMS, so on short message service. So we used to have the need to trigger a session with SMS, and now we've removed that need as well. So having the thing very much designed with constrained devices at heart, I think, is important. And then the third thing is flexibility in the remote management model. So this EIM, so this mega remote control, can be operated by so many different partners, so depending on the ecosystem and the use case and the needs. So it could be used, for example, by an MVNO who wishes to overcome permanent roaming restrictions, like I mentioned, or who wishes to access other profiles for cost optimization reasons or whatever. It could be operated by an enterprise who wish to manage their fleet of devices. It could be combined with a device management service to streamline the activation flows. It could be a hardware OEM who wishes to bundle connectivity with their offering. So there's many different partners who could operate this remote control, and I think that creates a lot of flexibility. And usually things that are flexible in IoT are better. People like the Lego brick approach and being able to kind of build their services like that.
One of the things I wanted to ask you, you've mentioned a couple of times, we talked about the edge devices, and there's often a level of, there's a constraint nature to them. We're seeing more AI kind of being implemented at the edge for cellular IoT. How is eSIM playing a role in the security of that? And because we know that's an area of growth.
I think we have two different scenarios. You have the very, very rich scenario, like a connected vehicle or autonomous vehicles, where AI is actually running locally at the edge of the network. And every sensor is including the cellular network and what's being received from the cloud or what's being received from maybe an edge site. It's absorbing all the information and it's making decisions locally. So that's the kind of rich scenario. But then most of the massive machine type IoT that we're seeing that's running over cellular are simply kind of collecting the information, sending it to the cloud, and and that's kind of the main use case. So back in I had the opportunity to speak back in at MWC in Shanghai in 2017, and I kind of firstly mentioned that we have this thing called that everybody kind of uses as an old cliche: data is the new oil. And back then I kind of said that, well, the security that's applied to the data must be directly proportional to its value, or the insights that will be automatically derived from it. So what I mean by this is that you might have some information that's publicly available. It could be an outdoor temperature, and that outdoor temperature, it's not a secret because anybody can find it out. However, if you have an algorithm that's running in the cloud somewhere that's going to, I don't know, for example, adapt the energy production based upon the temperature, then if that data is compromised, and if it starts, then we can start to kind of introduce problems into decision making or whatever. So again, the important thing is to protect the data sufficiently according to how it will be used, and it's firstly its own confidentiality, but also how it will be used. And this still holds true, but since we've elaborated a standard known as IoT SAFE, and so IoT SAFE runs in the eSIM, and it's a means by which we can protect the data confidentiality and integrity from where it's collected at the edge of the network to the cloud, where it's going to be processed. And so this kind of, from my perspective, is something which allows the EUICC to be used truly as a root of trust. Again, before the SIM card used to be delivered by one operator. Now the EUICC is an open platform that can be used. It's storing your wallet of potential SIM subscriptions or cellular subscriptions, but it can also be used to protect your end-to-end credentials. Now, another use case for this is that we also see that devices can transact between each other. So we start to see this concept, like I mentioned earlier on, of the economy of things, whereby we have devices that will seamlessly transact. So you might have an EV charger and a vehicle, an electric vehicle, and they might, the EV charger will provide energy, and both of them will form a transaction. And they might say, okay, I'm giving you this much energy and I'm accepting this much energy. They write a transaction. Each party signs using the SIM as a root of trust. And then that gets published off to a blockchain and it can be settled afterwards. So this is something which I think is going to become more and more visible over time. And again, it's a little bit like for those who've dabbled in any kind of blockchain type scenarios, or whether it's and any kind of cryptocurrency or whatever. It's a smart contract. It's a transaction which is just signed with a private key. And here we have a unique piece of hardware. It's available in every cellular IoT device, and I think it will eventually kind of propagate into non-cellular IoT devices. You'll start to see more and more kind of roots of trust, whether it's in the form of a TPM, a secure element, or whatever, that you need to be able to use to keep your private key safe and to be able to sign with. And I think the more and more we see that, the more and more that kind of builds into the protection of AI. And so, again, there's other things that can happen. We can also ease the device setup and onboarding and getting the credentials in place, which will also help the AI space to flourish. Because again, we all have this dream of IoT that you just literally turn something on and it just works. It's not always the case. There's sometimes some configuration to do, and it's a little bit messy. And I think both protecting the data, enabling the transactions, and firstly getting the credentials that we need to transact or to protect the data in place in an easy and simple way is extremely important.
That's a fantastic breakdown. I appreciate you kind of diving into that, because I think it's important for people to understand it's not just about the value of the data, but also what you're going to be doing with the data and how the data is impacting other things that are being done behind the scenes with the algorithm, things that are set up. I think that's really important to consider when it comes to thinking through how much security do you really need to put within a solution, or how much focus you really need to have around how secure the devices are, the solution is overall, which I think is great. Prior to wrapping up here, I did have a quick question I wanted to ask you, because I think is interesting to talk about is when new devices are rolled out. A lot of the questions that come from companies that are adopting solutions around the provisioning of those devices with the connectivity that they're going to have when they're launched. How has the provisioning of that initial connectivity by device OEMs changed because of eSIMs, the different eSIM variants, and what really needs to be taken into consideration kind of during that phase for people out there listening and trying to understand how this is going to potentially impact the solutions they're going to adopt?
I would say that there's been some quite significant evolutions in it. If I go back to my kind of earlier days, I had this vision, like many of my industry peers, that OEMs wanted to build a one-size-fits-all device with a single SKU, stock keeping unit. And literally, the same connectivity provider would be used in every single device, which would be called the bootstrap subscription. And then you would eventually kind of power on the device. You would see which country it happens to be in, and then you'd localize the subscription over the air. Now, this is all very fine for even things like, whether it's automotive, whether it's, kind of consumer devices. Some devices, this doesn't matter, especially devices with a rechargeable battery, devices that are running constantly on power, things like this. It's not an issue. However, you also have a whole range of devices that are built with a lifetime battery. So that could be, for example, a smart meter. And if you download a profile over the year, over, let's say, a very constrained network like NB-IoT or LTE-M, you could use maybe 10 or 15% of the battery just by downloading a profile over the year. And if you think about that, that could be maybe 2 years of the meter's lifetime. So it's a significant thing, and that's just to get the device set up. So so we've been working on this quite a lot in Kigen. We've been working with those who are in particular adopting these kind of low power networks with devices with built-in battery to try to get the right balance between the in-factory provisioning of the profile and then the in-field management. So, again, making sure that we don't have a mandatory step that's going to use some of our battery upfront. So GSMA have been working on a new standard, which is the SGP 41, which is addressing this. But again, it needs to be tailored for OEMs. And I've had the pleasure of visiting several different factories and walking around and trying to look at the different problems that they're trying to solve, looking at whether the factory has a connection to the internet in the place that they want to load profiles, having a look at whether the factory can be security certified, when they know which chip needs to receive which profile, these types of things. And we've been working across, visiting factories, working with industry partners across several sectors, including metering, automotive, consumer electronics. as well as the cellular module vendor partners that we have, to find the right solution for that according to the use cases. Because it's unfortunately not the one size fits all approach that we initially imagined with a single SKU and bootstrap. However, the important thing is to go to the factory, look around, ask questions, see what their constraints are. And then we've come up with several different solutions which is suited to different factory environments. And we really believe that getting the right subscription in at the beginning of the device, it can save a lot of headache afterwards. And anyway, it improves the user experience. If you're installing a power meter, if you're installing something, or especially in the water and gas meters, it's quite important to because they're the ones with the lifetime batteries. But if you're installing a meter, you don't want to be sitting looking at your watch waiting for the thing to get set up. It's a much better user experience for everybody. Just having the right subscription in at the time of installation.
The last thing I want to ask you before we wrap up here is tell me a little bit about what you all are doing when it comes to iSIM. I think that's something people are becoming or starting to learn about and understand how that differs from eSIM. But tell us a little bit about what that is and what you all as a company are really doing to bring that more to the mass market.
Integrated SIM is something that was actually pioneered by Kigen, because Kigen was initially founded by ARM. So we were incubated at ARM for several years, and ARM are of course massive players in the semiconductor IP space. So the integrated SIM technology, what that means is, so today we have the EUICC, which is an embedded UICC, which is a very, very small component. It's 6x6, if I remember correctly, and it has and that's millimeters. And it has a small tiny processor. It has some flash memory. It has kind of some security controls, and then it's packaged, if you like, kind of into a discrete chip. So the integrated SIM technology means that we can take that same processor with its tamper-resistant properties, and we can integrate it directly into the system-on-chip design. So you can basically design a chip with that tamper-resistant element inside, and then we mutualize the flash of the device which is already available. So in fact, it's like if you have a partition in your hard drive, you can have a secure partition which is encrypted with a kind of a BitLocker or something like that, whereby you can only access it by coming through the tamper-resistant element. So the integrated SIM technology, what it does is it's actually saving vastly on the footprint. So you can get rid of this additional component and all the logistics that's associated, all the, so it's one reel less to be putting into your PCB when you're dropping the different chips on and you're building your device. So that's the first thing. It becomes purely a digital enablement, whereby we can load the content of the iSIM, so the operating system and whatever your preferred connectivity profile together. So that's what we call a secure iSIM package. You can load that directly on your manufacturing line at a given touch point, or later on in the supply chain. So you can load that, and then it basically saves you the logistics. It's ultra power efficient. So you can save a vast amount of power. So we were talking about power constrained devices earlier on, and devices with lifetime battery. Things like asset trackers. Integrated SIM becomes extremely useful for maintaining the power, or things like smart meters where there's a lifetime battery and devices need to kind of last a certain number of years. And then again, the other thing is the logistics improvement. So typically the size, the footprint, the power, and and then ultimately it's extremely efficient, because you don't need to go outside of that system and chip to communicate with an external component. So therefore the reaction time is extremely lean, being able to talk to other components within the system on chip. So it's extremely efficient, extremely useful, and so we start to see a massive kind of we're kind of at the beginning of the hockey stick of the integrated SIM. It's becoming a reality. Many different OEMs are starting to design in the integrated SIM or leverage the integrated SIM technology where it's available. And I think we're going to see a lot more of that in the coming in the coming year already. We're going to see a lot more integrated SIM coming from a lot of the module vendor partners that we're working with, who'll be offering that by default in some of their kind of flagship devices.
For our audience who wants to learn more about what you're all doing, kind of stay up to date, maybe follow up on this conversation anyway, what's the best way they can do that?
On Kigen.com, we have a contact form. So that's one place to start. Otherwise, we have a LinkedIn page that you can reach out to us on. But on Kigen.com, there's a contact us form, and that would be probably the right place to start. And then one of the Kigen team will be in touch with the response to the query, and we can be able to talk you through what we're doing, whether it's integrated SIM, EUICC, IoT SAFE for protecting data end to end and using the SIM as a root of trust, or the in-factory provisioning, or any other remote SIM provisioning, or anything that falls into our kind of focus areas.
Well, Paul, thank you so much for taking the time. This is great to have you on and diving into a topic that I think is on top of a lot of people's mind, trying to understand kind of how it works, the role it's playing in the space, how it's contributing to that mass adoption, scale, global deployments like we talked about. So appreciate you jumping on, and excited to get this out to our audience.
Yeah, thanks a lot, Ryan, for having me. And I look forward to, if anybody has feedback, I look forward to hearing it. So thank you.